triangles? Anybody know?
Right.
Right triangles. Okay, so Pythagorean theorem deals with right triangles. Now, we've been working with radicals, haven't we been working with radicals, right? And in this chapter. And so why would the Pythagorean theorem end up falling in this, conversation with radicals? Well, it falls in the conversation with radicals because when we go to use it and solve it, we end up talking about certain components with radicals in it, meaning you're going to have 10.5 Pythagorean theorem. It works with right triangles only. So if we drew a right triangle and we made that a 90-degree angle, right? We've seen that symbol. Then we would, typically they label the sides as A, B, and then C. Anybody know the side opposite of the 90-degree side? What do we call that? The hypotenuse, right? You've probably heard that before from one of your 10 teachers in the last 2 years. Hopefully they use the word hypotenuse at some point. So, what?
Probably not. Probably not.
Probably not. Okay,
Just on the slanted side.
Hey, the slanted side. So this slanted side over here, yeah. So the hypotenuse. Now, the hypotenuse in a right triangle is your. Hey, Mrs. Elson. You guys know Mrs. Elson?
I don't exist.
Do you guys know Mrs. Elson? That is not my wife. You guys know my wife. This is my mother, Mrs. Elson. She used to teach here. Mom, they have
Now
had.
she's just a thief.
Yeah, now she's stealing from me. They have had how many math teachers in the last 2 years? Seven math teachers in the last 2 years.
What did you do to them?
Yeah.
They're the horror class.
But you want to hear something encouraging?
This one especially is lethal. I just feel like rolling over dead. He's so evil, so disrespectful and mocking. I could cry now just looking at your face.
Now you see what I threw up with.
I see why you're disappointed.
If only if any of my children could have been half as good as this young man, I would be on my knees before God.
I'll take on a quarter as good.
You are golden. I adore your father,
Oh.
who was a good influence on his best friend, Mr. Elson. Always good influence.
Yeah, good influence.
Okay, now do you want me to shut up?
Yeah, I do. You got it.
Can you tell me if there's any sugar-free pop food?
No, none.
None.
You could have the prime.
Wow.
That's like an electrolyte drink.
Where is it?
Those like ones in the very bottom.
It's like the.
Oh, no.
It's like a Gatorade type thing. Those
That's
are sugar free.
expensive. I can't steal expensive things. I'll just take the
But
one.
they said this is the first math class that's actually been consistent learning, and that's why it's hard. Isn't that great news?
Yeah, we're not used to learning.
What treats do you like? I'm coming tomorrow. I'll bring you whatever you want.
I mean, I'll take Coke.
You want Coke?
Yes, please.
A Coke. What else do you want? Donuts? Donuts?
Yeah.
What?
Donuts are good.
Donuts. Yeah, donuts.
Donuts and one Coke.
She's a lot funnier than me.
Really, for you to say that shows me that you are actual learners. And I taught high school for 35 years, and I had very few learners. People want to learn.
Well, they may not want to, but they do. They do a good job.
Well, that's good. That's a learner.
Yeah.
And I'm so proud of you all for saying that. So, donuts and a Coke.
Yeah.
Anybody else want a Coke?
You don't have to.
Hey, cool.
Anybody else want
This
a
is a
Coke?
grandmother.
I'll make Coke.
I'll
Okay,
take
donuts and 2 Cokes.
Better get 12 packs of
Donuts.
Coke.
How many? 1, 2, 3, 4.
Yeah, but
Five,
why don't you
six,
take the
seven,
donut order?
9.
Nora, what kind of donut you want?
Oh, come. Okay,
No,
all right.
otherwise you show up with like a bunch of jelly filled and people are like,
Okay, I'm sorry. Okay.
you know,
Okay, take the
you gotta
order.
Do it right.
Okay. Take
Go
the
on.
order instead of, I'll bring Cokes for everybody. Everybody want Diet Coke? I mean, that's sort of what I like because I need it. But
Oh.
Nora?
would you rather have Diet?
No, I'm okay. Nora.
Not that you need it.
Wait. IDK.
Will, what kind do you want?
Maple bar.
Oh.
Maple, that makes it easy.
Same.
Good.
I see
Okay,
rose
Chad.
in my future.
No, you should get cake donuts. I like
Anybody else want a maple?
Me. I do.
Who said me?
Me.
Maddie wants fungus, wants a maple,
Naomi.
and Naomi.
I am.
Maple.
Are you a
Who
fungi?
else? Who else wants a maple? Okay.
Sure, I like maples.
Sure. Try hard. You want a maple?
Try hard.
Try hard.
Try too hard.
She got like 100 on assignment. Some kid who's no longer with us is like, try hard.
I was good.
Michaela?
That's me, yeah.
There will be persecution in this life. You try hard and somebody
Milo, what
doesn't.
do you
Yeah, now
want?
he's wrestling.
I like fritter.
Fritter.
Apple fritter.
I want a fritter.
I'll take a fritter.
Fritter and a Coke.
Like a.
I'll take a,
Potomac.
I want a fritter.
Potomac.
Yeah.
Everybody has nicknames.
She's from Potomac.
Yeah, and you can tell.
Do you commute from Potomac?
Yes, ma'am.
Along the farmstead of the tree.
Why are you saying that?
I warned you. The drive of the century.
Thank you, thank you.
May the Lord protect you
Thank you.
from
Yeah.
oncoming traffic.
The drive is yeah.
Oh yeah, it's terrible driving. So.
It is scary.
Yeah.
Oh, she said, you drive yourself?
No, I don't.
You don't want
That's
to.
scary.
You get
Oh, yeah.
right. You get right.
I get, yeah, I just.
Okay, so Mr. Russell, I've wasted enough of your time.
Game.
So we want to, I don't know,
I'll send you the list.
You can be
Cake done. She wants a cake done.
Then you should erase that ID thing.
What did I do
That
with
was
my
my
drink?
drink user.
my water.
Oh, okay.
IDC.
No, it's IDC. I don't care. Oh, is this your paper too?
And it is by paper two and by paper one.
Yeah.
All right.
Yeah.
All right. I think you should get him to take this down. I think it mocks.
Why did you do that
And I
face?
don't like mockers. They are, in Psalm 1 it tells you.
Not
Never
mocking.
sit in the seat
Mocking
of
would be
mockers.
making fun of other people.
You're just mocking
Speaking
yourself.
of himself.
It makes fun of people who look like that. And there are people who do. He's not you.
Okay.
She's so funny.
It's been 7 minutes.
You should keep this on so I can show my parents this. You should turn the camera.
Evidence.
Okay.
Yes,
So,
right.
back to the Pythagorean theorem. The Pythagorean theorem states that the hypotenuse is the longest side. Okay, that's actually not what the Pythagorean theorem states, but the hypotenuse is the longest side. The Pythagorean theorem states this: is that you have the sum of the squares of the legs. So in a right triangle, the legs are not the hypotenuse; those are just the other two sides. So technically in a right triangle you have 3 sides, right? A triangle has 3 sides, but 2 of them are called legs of a right triangle, and then one of them is called the hypotenuse of the right triangle. So what it is a leg squared plus a leg squared is equal to the longest side hypotenuse squared. And when you involve squares, you're probably also going to get some square roots, and when you have square roots, that's what we've been working on. So, the sum of the squares will always equal the hypotenuse squared every single time if it is a right triangle. If it's not a right triangle, it's still going to be a triangle and have lengths, but they may not equal each other. So if I were to draw a triangle like this and say, okay, I have, let's make a measure, let's say I have 3 here, I have 5 here, and I have 6 there, and I say that's a right triangle. Now, I just drew that picture on the board, and I made up some lengths here, and I said it's a right triangle. You could verify that it is or isn't a right triangle by plugging into the Pythagorean theorem. If the Pythagorean theorem holds true, then you know you have correct lengths for that right triangle. So if we were to try this, we would look and say, okay, leg squared plus leg squared is equal to hypotenuse squared, hypotenuse being opposite of the 90. So we'd say 3 squared plus 5 squared is equal to 6 squared. And we'd say, right, 9 plus 25 is equal to 36. And you'd see that 34 is equal to 36. True or false?
False.
False. Therefore, was that actually a true picture? No, that is not a right triangle. Now, it does form a triangle, just not a right triangle. So that was incorrectly stated. Okay. Other things that you might have, though, let's do this one. If you say, okay, I have a, let's draw the picture again, a 3, a 4, and a 5. So if you have a 3, 4, 5, Now we check and say, okay, is this to verify a right triangle or not? We say 3 squared plus 4 squared is equal to 5 squared. We can do some mental math. Maybe 3 squared plus 4 squared is 9 plus 16. 9 plus 16 is 25. Does 25 equal 25? The answer is yes. Does that hold true for a right triangle? Yeah, it does. Now let's draw a triangle the other another way. And let's say we have a 8 and a 6 and a 10. Let me put a little right triangle symbol there. We say, okay, let's see what I have here. We have an 8, 6, and a 10. So this takes, we would take the legs again, and we say, okay, 8 squared plus 6 squared is equal to 10 squared. Okay, now, let's pick some easy W's for you. Jed, what's 8 squared?
81.
Nice. Okay, Madeline, what's 6 squared?
36.
Nice. Will, what's 10 squared?
100.
Okay, so Nora, what's 64 plus 36?
100.
Okay, does 100 equal 100?
Yes.
Done. Okay, is that a right triangle?
Yes.
Yeah, there we go. So now we do one more here. We're going to keep going just a little bit more on this. Let's say you have 12, 16, and 20. We call it a right triangle. It's okay. Does this equal a right triangle? Okay, so you guys go ahead. Give you a second to try this one on your own. And then we'll get some easy dubs again. Numbers are getting a little bit bigger. Going to push the envelope a little bit. Okay, but I'm giving you all ones that you should have memorized. No calculator necessary. Or you could do longhand, you know. So, okay, here we go. 12 squared, Jed. Easy W again.
144.
144, very good. Potomac, 16 squared.
256.
256. Milo, 20 squared.
400.
400. Does 400 equal 400? Yes, okay, there we go. Now, what we notice is, what I just gave us is a string of correct ones. What do you notice the relationship between this triangle, this triangle, this triangle, besides the fact that they're all right? What do you know the relation? Do you see any relationship?
Goes up by 1, goes up by 2,
So this one you had a 3, 4, 5. This one you had a 6, 8, 10. This one you had a 12, 16, 20. Yeah.
They all relate to they all relate to 3, 4, and 5.
Yeah, they all relate to 3, 4, 5. Like if you take a 3, 4, 5, multiply it all by 2, you get this. Multiply all this by 2, you get this. So this is actually what they call, that one right there, that is called a Pythag triple. Now, Pythag triple is a set of integers, so we don't deal with the decimals or the radicals, but a set of integers that will always form right triangles. So a 3, 4, 5 is a Pythag triple. Now what they actually don't do is, well, I mean, you can look up Pythag triples. Usually they don't include the multiples of the base, which is 3, 4, 5, and we multiply by 2, 6, 8, 10, 12, 16, 20, because then they'd have like an infinite amount like listed, which there are technically an infinite amount of these, but they usually just say 3, 4, 5 is a Pythag triple. If you see a 6, 8, 10 and you look at your Pythag triple roster, and you're like, I don't see it, well that's because they don't include the multiples thereof. What are other Pythag triples? Well, I can come back over here. You don't actually have to memorize these, they just make it a little bit easier for you. Is that in this you have, and you guys can't see it, but they list off a bunch of Pythag triples. Some of them are pretty big numbers, like a 65, 72, 97. Are you going to memorize that one? Probably not. Usually the ones that we end up memorizing are the 3, 4, 5, or multiples thereof, like the 6, 8, 10, the 12, 16, 20. We could have also multiplied this by 3 to call it a 9, 12, 15. That would also be a right triangle. And then, you know, at some point, if you wanted to come up here, you could look. There's the 5, 12, 13. That one you see sometimes. You see a 5, 12, 13, and then multiples of that. So if you see these in a triangle, you know guaranteed right triangle. If you see this, guaranteed right triangle. So worth noting or memorizing a little bit. I don't make people like memorize 20 Pythag triples, but those will always form, or like I said, multiples thereof. So you could have a 10, 24, 26. That's going to form one. Like I said, you can multiply this by 3, so it's a 9, 12, 15. That forms one. And then these other ones that I gave you there. Okay, so those are called Pythag triples. And you'll hear that phrase, you know, if you don't have me again next year and you're taking math and you're talking about right triangles, somebody's probably going to talk to you about a Pythag triple. So you can say, oh yeah, I did learn that from one of my 8 math teachers. So, Pythag triple. Now, let's do this. Okay, find the length of the unknown side. Find the length for the right. So now we're telling you it's a right triangle. So that's a triangle symbol. So I'm telling you it's a right triangle, and they have this picture drawn, and the picture is going to be, you know, B, A, C, and like this. There's your right symbol. And so your picture is going to have a, you know, they're going to tell you, they're going to say B is 12, C is 13, and A is equal to unknown, okay? So in this, if you know it's a right triangle, then you know it fits the Pythag theorem, and so we solve. Now, typically, C is always the hypotenuse, just in general, because that's the, but it doesn't have to be, unless they state it like here. Did they state that C is opposite of the 90? Yes, therefore, what is C always going to be? The hypotenuse. You could, however, like you could draw a picture and say, I'm going to draw a right triangle. I'm going to call this A, this B, and this C. Now, if that's what you did, what's the Pythag theorem for this picture? Because everybody says, once you memorize Pythag theorem, I say, hey, what's the Pythag theorem? Everybody says, A squared plus B squared equals C squared, which is true, but what if I change the picture? What's the Pythag theorem? B squared plus C squared equals A squared, right? So you have to make sure that you've got the correct picture that you're looking at. Okay, they did say C is the hypotenuse, therefore I know leg squared plus leg squared. That's the important part. So in this case, you would say A squared plus B squared is equal to 13 squared. And then you'd say, okay, this is, right, 169 minus 144 is 25. Just jumping the steps a little bit, right? But 169 minus 144 is 25. And then how do you solve for A in this case? Take the what of both sides? Square root. Now, typically when you take the square root of both sides, I think we worked with this. Don't you remember taking plus or minus? I don't know if you remember that, but you would say plus or minus, but in the case of a triangle, for this purpose, we're only working with the positive, so A would be 5. So you have a 5, 12, 13. Well, guess what? A 5, 12, 13, didn't you already know what the missing one was if you knew it was a right triangle? It's a 5, 12, 13. Now, not all of them are like that. Just that one worked out that way. But what happens if you have, let's do this, 2 and 5. Let's say this A is, now we'll call this number 2. So same picture. We're going to say A is 2, and then B is unknown, and C is 5. Now, this might almost look like, oh, it's a 3, 4, 5 or something, but it's got a 2 in there, so it's not going to be a Pythag triple most likely. It's not going to fall into the Pythag triple category. So we would need to, we look at the picture and say C is my hypotenuse, right? So I'm going to set up the Pythagorean theorem with my legs squared. So it's A squared plus B squared is equal to 5 squared. And we say, okay, oh, I'm sorry, A we knew. What was A? A was 2 squared. All right. So now I should show this step for you to make sure we're on the same page. 25, right? And you subtract 4 from both sides, so B squared is equal to 21. Then you take the square root of both sides. Is 21 a perfect square? No. And can you reduce 21 any farther in terms of radical form? Is there any perfect square that goes into 21 like we've worked with? And the answer is no. So there you just leave it just like that. Okay? Now, here we go. Is it a right triangle? We'll call this number 3. We kind of already did ones like this, but let's go ahead and do this one. What if you have 4, root 3, and 1? How do I look at that? They gave you 3 sides, and the question is it a right triangle? Well, the test for us to tell if it's a right triangle is, like we were kind of doing earlier, plug into the Pythagorean theorem. Now, when they give you the picture, it was nice and easy. You knew right where to plug in. How do I know which one's my leg, which one's my hypotenuse? How do I know? Or legs and the hypotenuse. Which one's the hypotenuse? 4. Why is it 4? I agree. It's the longest side. So you always know the hypotenuse is the longest side to test it, right? So the longest side would be 4 squared, and then you would go root 3 squared plus 1 squared, right, is equal to 4 squared. Now, what is the square root of 3 squared? I'm sorry, what is this? Yeah, the square root of 3 squared. The square root of 3 squared is square root of 3 times square root of 3, which is square root of 9, which is 3. Okay? Plus 1 squared is 1. 4 squared is 16. Yes or no? No. So like on the test, this one won't be on the MCA, so you don't have to worry about this. But like on the test, if I said show your work, rather than just writing yes or no, you would show this, and that's enough to be like, yeah, they don't equal each other, no. If you just looked at this and wrote no, by doing some mental math, I'd take off 3 points, give you 1 point for guessing no. So make sure you just show a couple steps to there, and then you would be set. Okay. Now, in the discussion of Pythagorean theorem, we also get into a discussion of the distance formula. I may have run out of room here. I don't know if I really want to start it here. Find the distance between the points. Okay, so we're going to find the distance between the points. We'll call this number 4, but I will 3, 2, and 9, 10. Okay. Let me erase this so I have some space over here to discuss the distance formula. We're going to do this, and I think we're going to pause. This will end up being a 2-day lecture. We'll tap some of this when we come back on Tuesday. So I'll end here. So find the distance between the 2 points. So what I'm looking at here is, if I were to graph these 2 points over here, 1, 2, 3, up 2, right? And so there's the point, and then over 9, 3, 4, 5, 6, 7, 8, 9, then up 10, somewhere up there. Okay, there's my 2 points. I want to find the distance between the 2 points. Okay. Now, I don't know, did you guys work with distance formula, like maybe in pre-algebra, possibly distance between 2 points on a coordinate plane? I'm not sure if you did. If you didn't, that's okay. We're going to give it to you again. And what the distance is that you can't count the distance between, because it's going at an angle across. It's not like I give you a horizontal line like this, and this is at 1 and this is at 5, and I'm like, what's the distance between 1 and 5? And you can say, oh, the distance is 4, right? Well, since it's going at an angle, you can't just count the distance. Okay. However, what we can use is the concept of the Pythagorean theorem. Meaning, what if I were to do a horizontal distance there and a horizontal distance here, right? I said this was 9, this was 3, this was up 2, and squeeze this over here, and this was up 10, right? Okay. So what I could actually do is, if I made a right triangle with this, couldn't I do Pythagorean theorem and say, if I know this distance here and I know this distance here, then can't I plug in the Pythagorean theorem and find that length there? You bet. So what is the distance right here? To go from here to here, what's that distance? That's just a horizontal line, right? You have 9 up to here and 3 up to there, so this is 6. What's the distance from here up to there?
8.
That's from 2 to 10, 8. And you might even recognize, is that one of our Pythagorean triples? It actually is, so you could do the hypotenuse off the top of your head if you've memorized the Pythagorean triples. If you don't, no problem, just do what theorem? Pythagorean theorem, which states, okay, 6 squared plus 8 squared is equal to this distance squared. And so you get, right, 64 plus, I'm sorry, 64. Oh, that goes through there. Let me erase that. 6 squared is 36. 8 squared is 64 is equal to d squared. You get 100 is equal to d squared. What does d equal? 10. There you go. So your distance is 10. Now you could memorize that, and like on the test, if you just wrote 10 without work, I'd say, great, you memorized your Pythagorean triples. Now you don't see a 6, 8, 10, but remember what I showed you over here is these are multiples. This is a multiple of that one. So you could see that and do it pretty quick. Oh, nice, I got a 6, 8, 10. So the distance formula, though, is, that's what we just did. We just did the distance, right? What we did the distance formula, you just didn't see it in a formalized formula. So the distance formula states for us, like running out of space here, that's fine, I can do it here. The distance formula says, what if I have a point here and a point here? And I call that, I go over x1 and I go up y1, whatever it is. We don't know what it is, it's just a general point. So this point is x1 comma y1. This, I go over x sub 2, so some distance, other distance for x, and then I go up y sub 2, some other distance for y. So then this coordinate point is x sub 2 comma y sub 2. So it just represents 2 points on a coordinate plane. Now I say, oh, well the Pythagorean theorem states the distance squared plus the distance squared is equal to this distance squared. So if we call that d for our distance, we would say the distance squared, right, is equal to the sum of these 2 distances. Well, how did you find this distance right here? You took 9 minus 3 to give you 6. So here we don't know what this number is, we don't know what this number is, but what I know is I take this minus this, x2 minus x1, and I square it, and then you add it, just like we did, we add it to the y distances subtracted from each other, y2 minus y1 quantity squared. And in the end, what did I do to find d? What did I have to do to both sides to find d at the very end? I took the square root of both sides. So your distance formula, you're actually going to see as this. They will take the square root of both sides like that. And they put that as a distance formula. Will you need to memorize the distance formula? Answer on this one is yes. I'm going to make you memorize the distance formula. A lot of people, though, they forget the distance formula, but you can track backwards and think through it as a Pythagorean theorem, because that's what it is, then you know that it actually hopefully makes sense. It's like, oh, that makes sense. We haven't done a bunch of examples, but it made sense, I think, for us to go 9 minus 3, giving us 6. Now we just have to convert that to stating x2 minus x1 gives us some value. And then it was, a squared plus b squared. So it's easier to look at here because I don't have a lot of x's or y's involved. Here, though, since we don't know what it is, you just take your 2x values, you subtract them, and you square them, which is the distance of this squared plus the distance of this squared is equal to that distance squared in a right triangle. So that's where our distance formula comes from. So you'll need that one memorized. Next Tuesday, we will cover, I'll I'll pick up the pieces and finish like midpoint formula, which you need to know for this 10-5. We're on 10-5. I had to pause and think for a second. So when we come back, we'll do 10.5 on Tuesday. So tomorrow, 10.1 through 10.4 on the MCA, no calculators, remember? And then when we come back, make sure, we probably won't grade 10.4 tomorrow, like we don't have time, right? But make sure when you come Tuesday, you have 10.4. Now track leads, other two track leads. I think you guys are gone tomorrow, and you're gone Tuesday, and then you're gone Friday. So you just have to pick up the pieces as we go.
Yep.
Or we'll help you, I'll help you.